Wait, what? Dang it, it was like super fast again. I wasn't ready for it. Welcome. It's late tonight, but you know what? We gotta get stuff done, okay? We gotta get stuff done. We gotta get this thing finished. So today we're gonna be finishing up our 3D model for our CNC module for the Snapmaker Artisan. This is a 200 watt CNC module. 200 watts, dang. I don't even know what, I forget what a watt is. I took an electrical class in college. Do I remember what a watt is? No. I don't. Ooh, it's like humid up here. The problem is I closed all the windows, I closed the door. I wanted it like nice and quiet in here, but it's a little hot. So this is where we ended up last Saturday, I believe it was Saturday. We have the majority of it finished. We have the base, we've got the actual like collet little holder down here, the actual, sorry, not the collet, the spindle. We have the actual spindle down here. Can I like hide this or something? Dang it. It's okay, I can see it down there. But we have the spindle, we have the fan vents, the electrical cord, and we started to do this back plate, which slides onto the quick connect plate of the actual Artisan. Turns out, I designed this pretty quickly on Saturday, near the end. It turns out it's on the wrong side. It has to be on the back. So we have to actually first go through and take this off and put it on the other side. So while I love the sketch, it's gotta go. It's got to go. Which we can go, by the way, to the base machine parts and go to tool head mount, and we kind of should be able to like, oh, I guess not. Maybe we can kind of take this same shape. Probably, I think we could take the same shape, and then it is a little rounded. We'll figure out what kind of roundedness it has. But this is where it's going to end up mating to, so we'll take that. We'll do add-ons, new browser tab. Okay. So on the back side, it's going to go on this side. We will start a sketch on plane. We actually probably could have kept that and just mirrored it over, actually. Oh well. We'll be fine. We'll be fine. Right, so how does this look? So it's gonna start out, we need to use this side here. And we're going to take this, go up like so, go across, and then come down, and we'll add the fillet in a little bit. Comes over, back down, and it creates our little surface there. So that's pretty good. So let's see, what is the dimension from here to here? There's gonna be 79 millimeters. 79. And let's kind of double check with our actual calipers here. This should be less than 79. It is 76.3. Perfect. Okay, so that's that. Now we can take, this may not be exactly perfect, I guess, because it's probably, but I guess we can take, what is this angle? 76.038. Let's, why did I have it as quite, why is that so specific? Oh my gosh, it's actually, that's not right. Is it? Oh, maybe, well, I don't know. Maybe it is. It's just needs to be smaller, I guess. Okay. how high is this off the face? We'll just say 7 millimeters. So from here to here is 7. So then how deep is it inside? Oh my gosh, this is like... I wanted some chill music. This is like hype. It's like 69 millimeters. I don't know if this is 69 millimeters or not. 75, yeah, that doesn't seem right. Why does that seem so off? Ooh, I wonder if it's because it's... Oh, it's probably going that way, isn't it? So what is this angle? 56.31. That's a much better angle. 56.31. There we go. That seems... That looks much better. Okay, we need to create a point on here. But we need to actually take this line off of here. So we need to take a point from here to here. Boom. Pivot. This needs to be horizontal. Oh, shoot. Oh, it needs to be vertical, I guess, technically. Coincide U to the U. And then take that. Oops, sorry, horizontal. Got my mind all over the place today. And then how big is this backside? 4.2 millimeters. By the way, this module is like heavy. Like you don't really, notice it too much, but holy moly. 4.2 millimeters. And then we'll take this. .45 millimeters. Sweet. 45 millimeters. Okay. And then what angle, what radius was that? 4 millimeter radius. It's probably not gonna want me to do that, is it? Because it kind of comes up, so we need to actually just create a spin. I can't create a radius. We'll have to just tangent a circle here. Boom. And of course that is a 4, so that needs to be an 8. And then actually that needs to not be tangent, it needs to be coincidental. Yeah, sweet. All right, and then we can go through and extrude. Bam, bam, bam. Go the other direction. And how far does this go? This goes 86 millimeters, let's say. 86 millimeters. Boom. There we go. Now we have the back. And that's pretty good. Okay. We do need to create a little bit of a radius on this. It actually is not super tight like that. What does this come out to? 76. So we gotta take, I don't really know how to figure that out. Maybe we'll just add a fillet. It's more like 1 millimeter probably. Can I get like the furthest distance? No, not that. No, not that. I want that. Maximum distance is what? 77. So maybe it is a little bit more. Maybe it is more like 1.5. Boom. 76. That looks good to me, yeah. Feels like it isn't that. I think it's more like 1. It doesn't look that crazy of a radius. Okay, awesome. Now on this side, we have to go through and create an angle. So on this face, we have to create an angle. How am I gonna, do I even have a, where even is my protractor? You know, I hate to inform you, I may have lost the protractor since, I think it's downstairs. Maybe I should get it so I can get this angle. No, it's gonna take way too long to get the protractor. It's gonna take longer for me to go downstairs and get the protractor than it is for me to actually just measure it. And just kind of like make it. I'm gonna say 8 millimeters from, let me see, I'm gonna position, can I use you? Coincide U to U. Dimension here is 8 millimeters. And then how far down is it? Oh, someone voted in our poll. You do. Computer aided design. Yeah, that's it. Good job, Anas. Wait, if I close the poll. Perfect, okay. Whew. Computer aided design or assisted, yes. I've always heard it as aided. But I'm pretty sure either will work. But Anas Osman, how you doing? Welcome to the stream today. I hope you're doing well. Hope you're having a good Thursday. One more day until Friday. Which now, it's actually even less than one day. It's pretty good. Almost there. Almost there. I'm just gonna assume that they're smart and they're gonna make the same dimensions on both sides, because there's a bit of a radius. You've heard assisted a few times? Gotcha. Yeah, I mean, either one works. So I can't fault anybody for doing that. And same thing. I always just hear everybody say aided. So what are we designing? We are currently designing a CNC module for my 3D printer. I have one of the 3-in-1s, so I've got a CNC module. The 3D printer module is downstairs on the actual machine itself, but the CNC and then the laser module is down next to me. So we are just designing these in CAD, so that way we can go through and actually like use them to either make a render, or if we want to design something for the 3D printer, we can also do that. Oh no, I'm punching a hole. Hold on. Up to face, up to there. Nailed it. And then we can add a fillet, because it's got a fillet. No, it's just a small one. It's like just enough to round the corner. Yeah, probably that's probably good. That looks so weird in CAD. But yeah, we're designing this. Oh shoot, I designed it on the wrong side. Designed it on the wrong side. I had this thing upside down. Okay. Boom. Rookie mistake. Oops. Okay. Good thing we already know what we're gonna dimension it to. Oh, wait. I thought you were gonna go inside to... Wait, what? Is this Fusion, SolidWorks, or a completely different software? Oh yeah, this is Onshape actually. It is a web program. Oh, that's why. Yes, this is Onshape. It is a web-based 3D modeling software and CAD software. It is free to use. You can create a free account, and you can use it on your computer. You can use it on like a Chromebook. You can use it on your phone. Having it on the phone is really interesting because if you're ever like, you know, we can be on our computers all day long and be like, oh my god, this design is so cool. And then you go out to, you know, a shop, or you go out like to like your job and you're like, oh my gosh, look at this awesome thing that I designed, and everyone's like, cool, can I see it? And you're like, it's at home. You can like pull it up on your phone and show everybody. It's really cool. Back when I was in college, I brought my my phone in, and I was like, yeah man, I'm making this lawnmower, it's pretty cool. And I was showing people like the design, and they're giving me like advice. They're like, I don't know if you want to do this, I don't think you want to do that, I don't think you want to do this, like, you know, have you thought about that? And I'm like, I have not, I appreciate it. And it was really cool. So very, very nice. Oh, okay. We took away that line, so we need to add that back. Coincide that to the point. And now, oh, that extra point is gone. Wait, why do I just have a bunch of extra? Let's got a bunch of extra points. Whatever. I don't know. Whoa, what happened here? Oh, it's like doing everything but that little bit. Okay. There you go. So, but yeah, we use Inventor and stuff at work, but I don't really feel like paying a ton of money for something like that. Dang, really? It's gonna get me on that little corner? Did it get me up here? Or did I? It did. Ooh. Boom. Okay, fill it that. Fill it that. Awesome. Okay, there we go. Now it looks now it looks better. Much nicer. Alright, how far in is this? If I go from here to here, take a maximum. That's just to a center distance though. I want like to the other area. This was at 3.6. .6 plus 5 5.35 calculator by 2 plus 3.6, so 6.28. Okay, we'll see. We'll match it up and see if it lines up eventually. And then down here, there's a little slot, and this is gonna have lines going over here. By the way, today, Tim Dodd, the Everyday Astronaut, released a video. Won't let me. Weird. Weird, weird, weird. .7. Okay. Wait, what? Why is this 4.7? Hmm? How wide is this thing? 76. It's not supposed to be down that low. 76. From there to there is 52. Oh, you know what? It's not. What is it? It's 45. Oh. Wait, where did I get that? It's supposed to be 45. .63. Okay, there we go. And then it goes right in. It's supposed to be a little bit higher though. .1. Why does it just go into the radius a little bit, maybe? We'll just see if it lines up with the maybe 4.6. didn't really do much, but all right. And then horizontal, boom, boom. Oh, we never measured the diameter actually. Duh. I'm like, why does that seem so big? 5.9. Okay. There we go. We'll leave that as 4.7 then. Seems like it should be bigger though. .9. Yeah, it's 5.9. Okay, and how far is it from? .09. It's a little bit off from that dimension. Oh yeah, no, that's way off. What in the world? Why is this thing way off? That's not what it's supposed to look like. Well, I guess actually maybe it is like that actually. Tangent that, and then we'll extrude this guy. Down 3.6. Remove. Boom. Okay, sweet. And then there's 2 holes. I don't think those are important though. Oh, does that have... No, there's not locating pins. I thought maybe there was. Maybe that's for like manufacturing or something. Okay, let me go to assembly. And then we'll insert our CNC module. So we have all of the machine built. Wait, what? Is that really a different, that's really a part, the second part? Oh man. Wait, why is that a second part? Where does it create the second part? Sweep. Oh, it needs to add. Merge scope. There we go. There we go. Okay, I'm like, why is there a... wait, do I need to update? Oh, hold on, I gotta go back to here. I gotta move everything back down. Okay. There we go. Now we go back into the model. And now... Gosh, hold on, I gotta turn on like perspective or something. So I can see where this thing actually is in space. Isometric sometimes just really hurts my brain. Sometimes. So we'll do a planar mate to you. Now we'll go back to isometric though. Oops, that's right. Perspective view. Move you down. Might be just a little hair. But that looks pretty good. How is the other side? So then we should build a planar made to you. And then how can I... Actually, no, I should be able to... What is it? I should be able to slider mate you to you. Boom. Oh, it's like a little off. How can I make this work? It's like really close. Hidden edges visible. I mean, that thing's like almost spot on. Okay, I don't think the slider mate is what we want. We'll delete that. Okay, how can I mate this? We can do... I guess I can just do a planar mate to you. And then can I do a planar mate from you to you. Wait, what? That should be locked in. Why does it not like that? It's so strange. Maybe instead of doing all this, let's just do like a fasten mate. Let me see here. Okay, if I do a fasten mate there to you, that should line everything up perfectly, right? Yep, that lines up spot on. That lines up. And then we'll check our hidden edges. And that is needs to be like a little bit bigger, I think. Oh, but do we ever dimension it from the edge? Oh, we did. It means need to be like 6.2. Oh, or it needs to go up just a hair. Okay, so that might need to be the... probably the 4.6. We were kind of teasing around with the slight numbers. There we go. That looks... okay, that looks really good. There we go. So now we can go to perspective view. And so now we can go through and actually move this entire machine. So we can move it any direction we want. We can go this way. Now, I have not designed the actual 3D bed. I have the heated bed. I need to go through and actually design the CNC carving platform. But sweet, that looks like good to me. I'm gonna leave the screws. Meh, I'm gonna leave the screws off. I guess we could do the screws. I guess why not? Why not go all out, right? We'll go on here. Okay. 8.9 millimeters. Pew, 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 pew. 8.9. 8.9. 8.9. Together they are 31.25. Okay, from the edge they are 6.5. Those seem really big. And 47. From you to you. And if we vertical these guys, sweet. And horizontal that, horizontal that. And then they can still move up and down though. So if we take a line here, do a midpoint, can you use this guy? they're like spot on. Boom. And then we'll inset them just a little bit. 1.1 millimeters. Boom, 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 boom. Add appearance. Boom. Nice. And we'll get you a side-by-side comparison. We'll get you into the light, I guess. That's not too bad. But this needs to be... Oh, this needs to... Okay, I'm on the wrong side now, actually. How far is this from here? That is 15.15. And that is 3.81. 11.34. It's actually on the wrong side. Oh, just needs to be the 3.81. There we go. Okay, now it's much better. Yeah, now everything lines up. Sweet. So I'm gonna go back over here now. This should now be closer to the edge. Yes. Awesome. Oh my gosh, what is happening? The entire stream is like falling apart. Internet, please? What are you doing? The internet is like gone. Hey, why is it, what the, why is it so crazy? What is up with this? I have no idea. Alright, but there is that. Hey, we're back. Okay. Sweet. Alright, so there is our CNC module. That looks complete to me. I would say that's pretty good. It's on the correct side. It's on the correct side of the actual model. We've got the fan, electrical port. We've got all the stuff. Ooh, well, I don't need to put the extra little browsing thing. That's fine. But I would call this done. That looks good to me. Ooh, much lighter. So, very similar looking. This is the laser module. It's going to be pretty much the same base, so we can start with the same stuff. A little different. We've got a couple of different circles on the bottom. There's a camera, a laser, a light. Same fan looking thing on top. So we already have that. We already have the mounting plate on the back, so that's good. You just copy that. So basically it's going to be pretty much the same. Dr. Hasbulla, welcome. Tobey Maguire? You know, it's really funny because honestly, for like the past 4 years, do the Bully Maguire dance? I don't know it. I don't know it. I've seen it, but I don't know what it is. I'll be honest with you. Alright, I'm gonna duplicate. But yeah, it's crazy how people like, I've gotten Tom Holland, whenever my hair is like growing out more, I've gotten Tom Holland. And then if it's short, I get Tobey Maguire. It's weird because so many people for years have been like, bro, you look like Spider-Man. Someone even left a comment like, you know, like a month ago. They're like, shouldn't you be busy being Spider-Man? I'm like, that's crazy. And like the first time somebody said it, I'm like, that's kind of interesting. Like, I don't really know how you get to that. But it's been like, and I'm like, okay, it must be like a one-off thing. But it's been happening for 4 years, so it's pretty interesting. But yeah, sadly, I am not Tobey Maguire. It'd be cool. Be nice. But alright, we'll name this the Artisan module. But Dr. Hasbulla, how you doing? Welcome to the stream today. Oops, Artisan module. Hope you're doing well. I'm cool? Oh, thank you. I appreciate that. Features. One feature failed to regenerate. Sketch 15. Oh, errors. If I just delete that, what happens? Oh, whoops. Oh, because he moved it, that's why. It's okay, those are all still good. What? Oh, because it doesn't like any of these. There we go. We should fix that on here as well. Yeah. It's weird how when you use something and then you get rid of it, you like change the dimension. It doesn't just move all the stuff that you used. It like leaves it alone. Oh, what the? Gotta select that. Okay. Sweet. Alright, so we need to figure out the height of this laser module. It is gonna be 85.75. How did we do this? We extruded that and then extruded this. Okay. It ended up being 79. What's this? 79.75. 79.75. And that gives us a total of 85.75. Is that like spot on? Oh my gosh, that is like actually spot on. Nice. That's like literally actually perfect. This looks like it's moved over. Oh no, we're good. We're good. This is 18.34. What is this one? Oh, I think this is longer actually, though. 114 millimeters. I think it's longer. Yes. 114. Sweet. This is based on the side distance, so this should be 20.8. 14. Hold on, I gotta get the other one out again. It's hard to grab. Okay, it is just moved over. So 20.8, we gotta move that. Oh, shoot. Alright, where's this one at? Dimension. Wait, how is this even dimensioned? Oh, it's dimensioned on this box, probably. Okay. $18. Boom. So then when you take this, 19.73. Got an extra millimeter. Got 19. Okay. And this other side is 18.4. Okay. Make that to 18.4. It is currently 11.384. I'm not really sure what I have to move it to. That seems really close to that. Okay, this is 18.5, let's say. Oh, so we just go back 0.7. For 2.3 millimeters. Oh, no, just go up 0.3. It's got a weird, it's doing this weird thing. Okay, let's say 42.5. Nice. $18.5. Nice. All right, sweet, spot on. Ooh, this CNC module is heavy. Plop. Put that back in the box. Back in the box it goes. Okay. Copied that, so we already have that. Now we need to go through and get rid of all of the CNC stuff down here. So that needs to go. The sweep. So all of this needs to be gone. Okay. We need to add, we'll add that as a chamfer at the end. On the bottom. $23.75. Nice, like almost nailed that. And let's see, from the front, it is Say 15 millimeters. I'm not gonna assume they're gonna be smart about it. 15. And from this side, it is 26. Oh, we're gonna go, actually, it's not gonna be, it's actually further down than that. $19 actually. There we go, a little bit more centered. And then it's actually gonna be $30. Oh, actually I added 4 both times, it's not too bad. Okay. Height is 16.15. There's a little chamfer down here. Goes out what? 3.5. Whoops. It's more like a 20-degree angle probably. I'm gonna do 2 millimeters. Probably needs to be like 25. And then we'll create the inside hole. 20 millimeters. Okay. So we'll end up using this. 20. And we'll extrude, remove, up to face, bam. Okay, awesome. So then we can hide, and what did we used what? Fasten mate was there to there, okay. So now we can go through, we can hide that, insert the laser module, and fasten you to you. Nice. And again, we can now go through, move the entire machine as you'd like. If you were interested, by the way, if you're like watching live or you're watching the VOD, these will eventually probably be up over at shoptusher.com. So eventually they'll be available for you to download. We also have the enclosure full assembly. I just need to put the side panels on. I need to go through downstairs and look at how these are assembled. I'm pretty sure this is the top up here for that filament holder. I just haven't gone through and assembled that yet, but I forgot, does the door open? Nope. Not really. Does everything else move below? Oh, nope, it's all fixed. So this must just be like slid in here. But yeah. This is it, man. Pretty cool. I'm a big fan. Big fan. Alrighty. Well, thank you for hanging out. Thank you for watching. We got the laser module done. We got the CNC module done. I might go through and add the like cameras and LEDs and stuff. We'll see. Maybe eventually. But I think for now, I think we're fine. I think we're good for now. So, but this thing's coming together. It's coming together. It's looking pretty good. I'm a big fan. If you want to, download this before it's even on the shop website, you can actually just go on Onshape and look up Snapmaker Artisan model, and you'll find it. It's a public document, so you can copy it, edit it, design stuff for your artisan. It's pretty good. So we have more stuff to 3D model. We need to model the beds, the laser bed, this bed, and then anything else to model? I'm not really sure. We already have the enclosure done, and then we might go through and do something else. I'm not sure if there's any other add-ons, but we will see. But thank you for hanging out. I appreciate it. Hope you have a good rest of your night. Hope everything goes well for you. Hope you enjoy your Friday. But yeah, thank you for hanging out. Thank you for watching. I appreciate it. See you next time.